Okay, so for problem 46, it starts as a continuation. I'm just going to write down the key point from 45 that is needed to know this. So you should have gone from 45 that sine of 90 plus x equals cosine of x. Um, and now it's asking to write the radian mode version. So I have the conversion on the right side of the screen. Um, so 90 degrees equals pi over 2 radians. So this should be sine pi over 2 plus x. And then equals cosine of x. Now it's asking to answer it. I don't I'm guessing it means to do the exact same thing from 45. So we're gonna do the angle addition formula. Sine pi over 2 times cosine of x plus cosine of pi over 2 sine of x. Sine pi over 2 is uh, 1. So 1 times cosine of x is cosine of x. Cosine of pi over 2 is 0. Times sine of x is 0. So this would equal cosine of x. So this is, I hope this is what the problem is asking for, but that's how to prove the radians still work. It's the same proof as 45, but instead of degrees, we just put it in radians. So. Okay, so from problem 47, this is where it starts getting a little more abstract and a little hard. So I would recommend that if you don't understand what I'm saying, to graph the equation on Desmos and manually look at where the x values stop, where the function is stop being described on the x value. Uh, the way you can do that, just look up how to find domain with domain, by the way, is this. How to find domain graphically. If you don't understand what I'm saying, I'm just gonna put that TLDR out there before I start. Anyways, so it states here that the inverse sine of x consists of numbers between -1 and 1 inclusive. What is the domain of inverse cosine? So the reason why sine, I'm just gonna draw this right here. If we draw a circle, the reason why inverse sine only consists between -1 and 1 as x values is because the max sine can be, right, if sine is the y value, is 1 and then -1 technically. In the same aspect, right, the domain of inverse cosine of x should only also be only 1 and -1 because it's a unit circle. That makes sense. Um, that is my only way of describing it. By the way, I use brackets. Brackets means inclusive, meaning that it can be -1 and 1. There's going to be times I use parentheses for either side or both sides, and that means it doesn't include that. That's called interval notation. You can look that up if you are still confused. But this is, I guess, the only explanation I have for this, for cosine, is that you cannot have more than 1 or -1, or less than -1 and more than 1, because a unit circle just cannot have that radius if that makes sense. Anyways, so I hope that makes sense. And now it's asking for the domain of the square root function. So the square root function is f of x equals root x. And here, this is another time where you have to use a little bit of critical, like just a little bit of thinking here. You can't have a negative number as x. Uh, or sorry, you can't have a negative number for y. uh, it won't work because you can't have a square root of a number be negative. So it, right, like if f of x is -3, there's no value of square root of 3, the square root of x that will equal negative any negative number. So it has to be greater than 0. Um, so how we would format this is the domain of square root of x equals 0, because it could include 0 technically, uh, to infinity, right? Because you can have any number of x that's positively, right? You can have any value of x that's positive. Like square root of 100 is 10, square root of 1,000, square root of 10,000 is 100. Um, and you can keep going up and up and up and up. So that's why it's infinity, but it cannot be negative because you literally cannot square root a number that would be negative. Um, for now it's okay. After that, it's asking for the domain of log. And log has the same idea of square root. You cannot have 0 or below. Well, this time you just cannot even have 0. Because right, you can think of any number, right? Any number, right? 10 to what number equals x? That's basically what this is. I just converted this into the inverse, right? The inverse log is the exponential. Um, if x is greater, if x is less than or equal to 0, what y value does that make? Well, you could plug in any y value. If y is 0, 10 to the 0 is 1. If you go low, let's say you do 1/2, or let's say if you do negative 2, right? It just turns into a fraction. It's still positively oriented. It cannot be 0 or negative. And you can just plug in random numbers, or even graph it, and you can mention that. But unlike square root, it cannot be 0. You cannot find any exponential to equal 0 or any negative numbers. So I'm going to write this as the domain of log of x equals, and then here I'm using parentheses because it cannot be 0, and then infinity. Okay. Now it's asking for the domain of the exponential. So f of x equals, it says exponential, so it could be any base, but I'm just gonna for uh you know just the sake of math, I'm just gonna use e to the x, which e in this case, if you don't know what e is just a number. It's like 2.718. But it's like special like pi, so it has its own uh symbol for it. The domain of this is you can plug in any value of x. You'll get an answer. Um, I'm trying to think if there's any y value that cannot be achieved. Oh, 0. Yeah. Same thing with the log, I guess. I'm gonna make sure. I'm just gonna check on Desmos real quick that graphically. Uh, no, never mind. I forgot because when if it you could still have because negative exponent doesn't make it negative. It makes it smaller and smaller. So actually, I think every number is achievable here. So we would say the domain of the exponential is from negative infinity to infinity, which means that it reaches every single number. Now, again, I apologize. I know this might seem very hard to understand or advanced. I would really just recommend if you do not understand this to go on Desmos, literally look at the graph. If x stops at any place, that is the domain. And look up what a domain is if you are more confused from that. If you understand this, that's great. This is the called union slash interval notation. Uh, and if you're also curious, you can also just look it up. Anyways, the next problem is going to be on range, so we're going to go more on that on the next problem. Okay, now we're on range, and range is a little more. I would say it's actually harder than domain. Uh, but it's the same idea. So instead of with domain, we try to find any y value where x doesn't exist. It's the other way around. We're trying to find any x value that y doesn't exist. And again, I will preface this again. If you do not understand the domain, how I did domain, I would highly recommend just go on Desmos, graph the function, and see where the y stops. and the negative in the positive. And I actually recommend doing that instead of listening to me ramble about how to do range because I think that's much easier to do. But if you know you want to if you want to be here and learn about how to do this, um, we're trying to find out what x values exist, um, so where y doesn't exist, or where it keeps going. So it's asking for the range of sine inverse sine of x, since all numbers between -90 and 90 inclusive. What is the range of cosine inverse? Here you don't even need to know about range. We know that cosine and sine are related, so we know that the range of inverse cosine of x equals again, I'm going to use the same notation, inclusive interval of -90 to 90. And this is in degree mode, by the way. Again, I will not draw the unit circle again, but just like sine, which ranges from -1 to 1 as the radius, cosine also does the same thing, right? So that means that at -1 and 1, the angle is 90 degrees and -90 degrees, so cosine should also be -90 degrees and 90 degrees. It's similar like that. What is the range of the square root function? Um, x cannot be negative. Uh, I think that's. I hope that's a little bit self-explanatory. Um, because what happens when x is negative? So if x is -2, -3, -4, -5, it becomes an imaginary number, a complex number, which we're not going into yet, but it's not doesn't exist theoretically, right? It doesn't exist in the math we are doing right now. So we just totally ignore it. We know we can't have a square root of a negative number, and we move on. So this would be but zero still works, right? Unlike log, zero still works. The square root of zero is zero. So we have inclusive 0 to infinity, right? Because you could have any x value, right? That's positively oriented. You could have like 100, 1,000, a billion, like. So again, in the same vein, it would be infinity. Again, with the parentheses, because technically infinity is not a number. Okay, now let's go to the next one. Range of the logs function. Uh, you can't have you. I'm pretty sure that this is infinite, just by like intuition. Um, because you can plug in any value of x, right? If it's 10 to the x, 10 x could be any number. Yeah, x could be any number, right? It could be -5, -10, a billion. Like, so I actually think this is from negative infinity to infinity. Hopefully, I'm right. You can also graph it. And you can see. Um, now I do gotta preface that x needs to get you can't visually see it because when x is like 2, right? It's or when x is like what I'm trying to say is that x has to be a very big number to see a change in the y-axis, right? Because if x is 100, then y would only be 2 in this case, right? Because 10 to the 2 is 100. So it's gonna be while it might look like it stops at a y value, it doesn't. It just increases in the y-axis very slowly. So um, I'm pretty sure that's yeah, that's that. But I think oh, there is there an exponential? Oh, there is not an exponential yet. I see. Actually, I saw the last part of the question. It's asking for the exponential, but now it's saying what is the range of this f of x? So I'm just gonna write range of f of x. Okay, 2 minus 7 sine 45 x. So you again, if you need to, and you can just always graph this on Desmos. I'm doing that right now, actually. Um, and here, what does this say? I'm on radian mode, am I? Yeah, degree mode. Okay, so now I'm using Desmos to check my answers. Uh, but I don't think you need that. But okay, again, we could split this equation up. So I'm gonna write this equation down. Down here is 2 minus sine 7 sine 45x. Oh, that's it. When you constants will stay constants no matter what, right? It's 2 and 7 are never changing no matter what x is, right? Because 7 is just not x, right? Because like I guess I hope that's self-explanatory that 2 and 7 will change because they're not x. But sine 45x will, and we already know from what they gave us that the range of the inverse sine function is -1 and 1. So if we want to find what x is, right, we would have to find the inverse sign. I'm not going to do that because I hope that you understand that if you want to isolate x in a side equation, you would find the inverse sign, and then the inverse sign has a domain. So I'm just yeah, I guess I'm just gonna assume that uh you know that. Um, so this would either be -1 or 1. Uh, right, because it doesn't matter what x is, right? It doesn't matter what the amplitude of x is. It doesn't change the fact that the maximum value is -1 or 1. So this means that y could either equal 2 minus 7 times -1, which is 9, or 1 times 7 is 7, 2 minus 7 is -5. And it's not an or actually, sorry. I should not write or, it's and. Because if you like look at a graph and you like look at the sine function, which I don't know where the intercept is, but it looks like this. This would be 9, this would be -5 in the y place. Um, but that gives us the range. So this would be inclusive 9 to -5, or other way around, -5 to 9. I know I went through this really fast. The main thing is sine. You just gotta understand that sine 45 of x has the same domain as inverse sine because we have to isolate x, and then the constants don't change because of x. It still stays constant, and that's actually very important for later. And then I just did math, multiplication, and yeah, I got that. Um, again, if you don't understand what I said, graph it on Desmos and look. Okay, so now it's looking for the range of b of x, or b to the x. Uh, so what value of x that uh y doesn't, no, what value of y, I just had a brain fart. What value of x so that y exists? Um, I'm pretty sure that any value of, no, why am I, okay, hello. Okay, I'm back. Sorry. I'm really just like out of it right now. It's midnight. Yeah, you can't have, so it's as what x value does y exist? Uh you can't have a negative y because there's no value of x you can give that gives y. I got confused with logs, that's why, because they're inverse of each other and range and domain are inverse, so I got mixed up. Um but yeah, this should just be 0 to infinity. Just like the log on the other question. And the reason why is because you can't have any x. So 10 or b, whatever b is, right? Doesn't matter what b is. Unless B is negative, I just realized. Yeah, B could be negative. I just realized that, but let's assume B is positively oriented. If B is negative, it gets very weird, so I'm just gonna ignore that. If B is positively oriented, then it will stay the same as the log function as the domain, if that makes sense. Anyway, sorry. That yeah. I'm probably gonna cut where I paused for like 30 seconds. But yeah, it was brain fart for me. But anyways, those are the three problems. Range, yeah, domain and range are really hard to understand mathematically wise. So if you visually just look on Desmos, you graph all of them, and you look up how to get information on domain and range just by looking at it, then you'll be fine. All right, peace out.